Test over rational functions. Number 1, identify the y-intercept. To identify the y-intercept, you plug 0 in for x. So 0 squared minus 4 times 0 plus 5. 0 squared plus 3 times 0 minus 1. So your y-intercept will be at 5 over negative 1, which is equal to negative 5. Writing that as a coordinate, since I plugged 0 in for x, 0, comma, negative 5. That is your y-intercept. Number 2, find the equation of the horizontal / oblique asymptote. Since the degree of the numerator is 1 more than the degree of the denominator, we have an oblique asymptote. To find the oblique asymptote, we divide using long division. So we're going to have, underneath, we're going to have 2x squared plus 5x plus 2, dividing that by x plus 6. So we're going to multiply x times 2x to get 2x squared, and then 6 times 2x to get 12x. 2x squared minus 2x squared is 0. 5x minus 12x is negative 7x. Bring down the plus 2. Alright, x times what is negative 7x? Negative 7. So negative 7 times x. Negative 7 times 6. Subtracting. Negative 7x minus negative 7x is 0. 2 minus negative 42 is 44. Since this is our remainder, we discard that. This is our oblique asymptote. Y equals 2x minus 7. Find the root of the function. So to find the roots of the function, we set the numerator equal to 0. And then we solve. Well, since this is easily factorable, I'm going to go ahead and factor it. So we have x plus 3 times x minus 2. And now we know that our two roots are at negative 3 and positive 2. Number 4, list any vertical asymptotes. Vertical asymptotes are found by putting the denominator equal to 0. So we get x cubed plus 2x squared plus 1x. Set that equal to 0. Well, right off the bat, I notice there's an x in each term. So I'm going to factor out an x by dividing each term by x. Then I'm going to factor this. This factors to x plus 1 times x plus 1. So our first vertical asymptote is at x. Set the first factor equal to 0, x equals 0. And since these factors are the same, our second vertical asymptote is found at x equals negative 1. So x equals 0 and x equals negative 1. Number 5. Given this rational function, find any horizontal or oblique asymptotes. Notice that the degrees are the same. Since the degrees are the same, we have a horizontal asymptote. And to write the equation, we use y equals a over b. Well, a in this case is 2, b, in this case, is 4. So 2 over 4, which is 1/2. Y equals 1/2. That is your horizontal asymptote. All right, given this rational function, do these things. Let's start off with b. Give the roots if they exist. Remember, to find the roots, we have to set the numerator equal to 0 and solve. So part b, x squared plus x minus 2 equals 0. And let's see, coming up with those roots. X plus 2 times x minus 1 should do the trick. So we have a root at x equals -2 and x equals 1. So I'm going to go ahead and put those on here right now. So we have a root at x equals -2 and 1. Okay. Now, give the vertical asymptotes if they exist. Remember, vertical asymptotes, set the denominator equal to 0 and solve. So x equals 2. So at x equals 2, we have a vertical asymptote. All right. Give the horizontal / oblique asymptotes if they exist. Looking at the degrees, this degree is 1 more than this. So we have a correct oblique asymptote. And we must use correct long division. So let's go ahead and do that right over here. This is part D. So we're going to have x squared plus x minus 2 divided by x minus 2. So x times what is x squared? Correct? So x times x is x squared. X times -2 is -2x. X squared minus x squared is 0. 1x minus -2x is 3x. Bring down the minus 2. X times what is 3x? 3. 3 times x is 3x. 3 times -2 is -6. Subtract. That's 0. -2 minus -6 is 4. There's our remainder. We don't need it. This is our oblique asymptote. Y equals x plus 3. All right, let's graph that line. Y-intercept is 3. Slope is 1. Rise 1, run 1. Rise 1, run 1. So keeping the slope of 1. Go in both directions. I'm going to pause it here. All right, now we have our oblique asymptote. Next, it says give the y-intercept if it exists. So to find the y-intercept, remember we plug 0 in for x, so I plug 0 in for x. Solving this, -2 on top, -2 on the bottom, gives us a y-intercept of 1. So it crosses the y-axis at 1. All right, so now it says specify 2 additional points on the graph. Well, we know that the graph is going to be down here. We have these 3 points right here, so we can kind of make a sketch of what this is going to look like down here. But where's the rest of it? Well, we need to test some points. We got 1, 2, let's test x equals 3 and see where that puts us. So at x equals 3. So going back up here, we're going to plug 3 in. So we're going to have 3 squared, which is 9, plus 3 minus 2 over 3 minus 2, which is 1. 9 plus 3 is 12. 12 minus 2 is 10. 10 divided by 1 is 10. So when x is 9, when x is 3, y is 10. Alright, so we know where that's going to put us. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's one additional point. We need 2. So let's go ahead and get 4 as well. 4 squared, 16, plus 4, minus 2. 4 minus 2 is 2. 16 plus 4 is 20. 20 minus 2 is 18. 18 divided by 2 is 9. So when x is 4, y is 9. So let's plot that point. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we can kind of draw in the rest of this graph and get an idea of what this is going to look like. Alright, moving on. Number 7, subtracting rationals. When subtracting and adding, you have to find a common denominator. So the best thing to do is to just multiply these together to get a common denominator. So this denominator needs a 2v. So if I multiply the bottom by 2v, I multiply the top by 2v. This denominator needs a 3v minus 4. Multiply the bottom, so you have to multiply the top. Now we have a common denominator. We can go ahead and subtract. So 6v times 2v is 12v squared. Okay. Distributing the negative 3. Remember, subtracting is the same thing as adding a negative. So when we're distributing a negative 3. So negative 3 times 3v, negative 3 times negative 4. And this is going to be over 3v minus 4 times 2v. Alright, an important note. When simplifying, you want it to be as factored as far as possible. If you'll notice here, all 3 of these terms are divisible by 3. So we could take a 3 out of each term. We get 4v squared minus 3v plus 4 over our denominator. Now, at this point, we should try factoring this, but it is not factorable. So this will be our final simplified answer. Alright, let's take a look at this one over here. Now notice this one. This one has an f squared minus 3f. It has a 4, and there's an f. So, what does the first rational need? It needs a 4, and it needs an f squared minus 3f. Well, we could factor an f out of both of these terms if we wanted to. So notice I factored an f out of both terms, and that gave me an f minus 3. Did the same thing with this one over here. Always remember to factor everything. So 2 has an f, but it needs an f minus 3. It also needs a 4. Okay, plus 3 needs, well, it has an f, and it has an f minus 3. It just needs a 4. And the 1 has everything. So remember, once you have a common